Section 5.5, inequalities involving two triangles. So yesterday in our lesson we were talking about how angles are going to correspond with the opposite side length in any triangle. So if you have a really small angle in a triangle, the side that's opposite to that side is going to be really small, this side up here. But if you have an angle that's really large in a triangle, then that opposite side is going to be really long. Okay? Today we're going to look at the same kind of lesson, only we're going to have two different triangles we're going to be considering. Okay? Let's look at this theorem in your SGI book on the front side of 5.5. SAS inequality theorem, or in other words it's called the hinge theorem. Okay, let's read this one together. If two sides of a triangle are congruent to two sides of another triangle, and the included angle in one triangle has a greater measure than the included angle in the other, then the third side of the first triangle is going to be longer than the third side of the second triangle. Now, here's an example. Look at these two different triangles. And let me tell you, on these problems, there's going to be consistency that you're going to see. You're going to be given two triangles. But here's the consistency. It's always got to tell you that you have one side on this triangle congruent to one side over here on the right triangle. But then you're going to have another side. Another side over here is going to be congruent to another side over here. So they're going to have two sides of each triangle that are fixed and that are congruent to each other. Okay? So what we're going to look at is this angle in the middle. How big is that angle? Okay? So what you're going to have here is, take this for example. If you have a measure that is 4 inches long and you have another measure that is 2 inches long, and let's say that these are like two sides of a triangle. Okay? Now, can you, with your mind, with your imagination, can you connect this third side that's going to meet this shorter segment and this longer segment? Okay, look at that third side. Okay, what we talked about yesterday is if you make this angle in the middle smaller, then it's going to make this opposite side get shorter. If you make this angle bigger, then it's going to get this opposite side, it's going to make this opposite side longer. Okay? But I want you to think with me, I want you to consider, what if we had a triangle and we made this angle really small and we connected this in our minds and we took a snapshot of this triangle. Okay? And then we had that picture there, and then let's just scoot over here and let's make another triangle where we change it. We're just changing the angle in the middle. Now, let me ask you, from that snapshot we just took in our minds to this situation right here, did we change the length of this short segment? No, it's still 2 inches. We didn't grow it or we didn't shrink it. Did we change the length of this 4 inches? No, it's still 4 inches. It didn't grow any, it didn't shrink any. Okay, so here are your two segments. These are always going to be set in place. We can have two different triangles, and if we know that we have two segments that are staying the same after we change these angles, if these two segments are staying the same, we can compare these two triangles. Okay? This is how we can compare them. It's going to ask you to tell about the opposite sides, and let's compare the opposite sides. Okay? So here we go. If we have an angle measure of 80 and an angle measure of 60, okay, well, which one do you think is going to be bigger? Do you think this RT that's across from the 80 is going to be bigger, or do you think that the AC across from 60 is going to be bigger? The one that is across from the larger angle is going to be the side that is the longer side. Okay? Your questions are going to ask you compare the length of RT to the length of AC, and what you're going to have to do is just say, is it going to be greater than or is it going to be less than? RT is across from the greater measure. Therefore, it is going to be greater than AC, which is across from the smaller measure. Okay? So, a couple little tricks here. This is what I would advise you to do when you get a problem like this. Take and write, if you're looking at RC, write down this angle measure that corresponds with it. The angle that's opposite is 80 degrees. It kind of goes together here. And then 60 degrees, write that underneath your AC. Okay, so just compare 80 degrees, 60 degrees. 80 is greater than 60. Therefore, RT has to be greater than AC. Okay, let's try a few of these together. On your SGI book, we are going to do number 1 together. Okay. Now, here is a little bit of a different setup. This number 1 here, it does not give you 2 separated triangles. It puts 2 triangles together. Okay, so what you want to look for first is, do we have these set lengths? We need two sides in one triangle to be the same as the corresponding 2 sides of the other triangle. We always need that as a setup. So I want you to do this. I know that there's congruency marks here on MN and PN, but I want you to take your pencil and I want you to highlight them, make them bolder, because we really want to tell ourselves there's some congruent sides. Where is the other side in both of these triangles that is going to be the congruent side? Well, don't they share this side RN? So isn't RN the same length in the top triangle as it is in the bottom triangle? Yes, we can say that. So here's what you want to do. Mark this segment in the middle. Mark it congruent to itself, because it's used in the top, it's used in the bottom. Do you see your 2 sides congruent now? Here's a side, here's a side. We are going to focus on the angle in the middle, and look what it's going to ask you about. It's going to ask you about MR and RP, and that's going to be those third sides that's across from that angle that you're given. Okay, so here we go. Let's look at MR and then the measure of side RP, and we're going to say, is MR greater than RP or is MR less than RP? Okay, so what you're going to compare is, all right, MR, here it is. What is the measure, the angle measure that is across from it? It goes with 21 degrees. Okay, and let's find RP. Here it is. What is the angle measure that is across from RP? 19 degrees. So that's the one that's going to correspond with RP. So now just ask yourself, 21, is it greater than or less than 19? 21 is greater than 19, obviously. So therefore, the side opposite your greater angle measure is going to be greater than the side opposite the lesser measure. Okay, this is your answer. Compare these two. MR is greater than RP. Okay, how about we try one more? And there's one more different setup that you may find as you are working these problems. You do need to go back and do any problems that we skip over. You are responsible for all these. Okay? But I do want to skip to number 3 and look at this one because it's a little bit different. Okay? Now, do you see the difference in number 3 setup and then the setup that we had for number 1 back there? Okay, here's the difference. You've got some numbers going on in here, like some extra numbers. Okay? What are those about? These numbers, 42, 42, they give you these numbers because they want you to see that EF is the same measure as HJ. If they're both 42, they're congruent to each other. Now, if lots of numbers in here are going to mess you up, this is a good trick. This may help some of you. After you see that 42 and 42 are the same, mark in these congruency marks. After you do that, you don't need that 42 anymore. We do not need to look at 42 anymore. The only reason they gave you that is so you can see these sides are congruent. Okay? Now, let's look at some other numbers they give you. 10 is here, 10 is here. They give you those numbers so that you can just obviously see that FG is the same size as JK. Okay? Now, once you put that on your page, once you mark those congruent, you're done with those. That's the only reason they gave you those 10s, is to say that this piece is congruent to this piece. Okay? All right. What we're going to do here is we are going to compare side EG with side HK. Okay? So here we go. EG is greater than or less than HK. You're going to consider, here's EG. What's the angle measure that's opposite? 60 degrees. Here's HK. What's the angle measure that's opposite? 62 degrees. Okay, so compare them. 60 is less than 62. So therefore, the side opposite, EG, has to be less than the side opposite is 62, which is HK. Okay, there's your answer. It's as easy as that.